morning, guys. Okay, some of you emailed me some problems, so I'm going to start with the homework problems from page 327. This was that worksheet that I sent you. Okay, this was solving equation using the sum and identities formula. So you do realize that you have an identity here and an identity here. So the first thing you have to do is write out the identity. The cosine of the sum of two angles gets written out as the cosine. Remember, this is your A, this is your B. The cosine of 3 pi over 2 cosine x. It's plus, so it becomes minus. Then it's sine 3 pi over 2 sine x plus. Now this is the sine identity, so we expand this one. It's going to be the sine of 3 pi over 2 cosine x minus cosine 3 pi over 2 sine x equals 0. Okay, and again, those are just the formulas that I haven't memorized, but after a while you say them so much you remember them, and I was just writing it out. So that's it, you're just expanding it. Now you're actually going to put in the values. What is the cosine of 3 pi over 2? Well, that's 0. So technically, guys, this is 0 times the cosine of x minus the sine is -1, excuse me, times the sine of x plus the sine, again, we already said, is -1 times cosine x minus the cosine is 0 times, the sine of x equals 0. Well, this is gone because it's a 0. This is gone, it's a 0. So negative times negative is positive. So this is just going to be a positive sine x plus, this is, well, actually I could write negative because it's negative, minus cosine x. Okay, so equals 0. This is the one that I told you about in the explanation. I'm going to bring cosine to the other side. When is the sine of some angle equal to the cosine of that angle? Well, at pi over 4, the sine and the cosine are the same. So when x is pi over 4, okay, in quadrant 1, when they're both positive. Also, when they are both negative. They are both negative in quadrant 3, which would be 5 pi over 4. In the other two quadrants, in here, only sine's positive, so this would be positive, this would be negative. They wouldn't be equal. And over here, only this one is positive, cosine, so they would not be equal. Okay? Okay, yeah, now I know the tan one was a little challenging. Okay? So if you looked, they're the same ones. Now, some of you put them together. You can't do that. Okay? It doesn't really work out that way. But what I did is I realized that when I expanded this, whatever I get for this, I'm going to get for this. So rather than write the whole thing out like this on my homework paper, and that might have confused you guys, I wrote it out just once. So that's what I did. Using the tan formula, which is a pain in the neck, it's not my favorite, tan of pi minus the tan of x. I'm just doing the formula from the paper, using this is my A, this is my B, is 1. Is this minus or plus? Now I forget. Minus, I think it's plus, the tan theta tan x. I'm going to pause the video for a second because I really think, okay, I'm right, it is a plus. I think on my paper I put minus, that might have confused everybody. Okay, what is the tangent of pi? Remember, pi is over here, all right? Its sine is, you go over -1, its cosine is 0. Okay, when you put 0 over 1, the tangent of that is 0. So this is 0. This is gone. Okay, so if that means in the numerator, I'm just left with the negative tangent of x over, okay, this is 1 plus, this is 0. 0 times that is 0 over 1. So this whole thing simplifies to a negative tan. If this one becomes a negative tan, this one becomes a negative tan. Okay, if you just work it through, it really makes sense. Okay, again, this is 0. 0 minus tan is negative tan. Okay, this is 1 plus 0, so it's 1. So now I have negative 2 tan x equals negative 2. Divide both sides by negative 2. I have tangent of x equals 1. And who has a tangent of 1? Oh, it's our pi over 4 again. All right, and tangent is positive in quadrant 3, 1 and 3. Okay, so that's what happened with that. Okay. This was another question people sent me from that homework, but again, it's the same thing, guys. You just have to expand it. First, I will expand the sign. I'm watching the time because it gives me a time limit to make these videos. Sine x cosine pi over 3 plus cosine x sine pi over 3. This is a negative, so plus sine x cosine pi over 3 minus, because it's a minus, cosine x sine pi over 3 equals 1. Okay, so now I'm going to put in the values I know. I know what the cosine of pi over 3 is, so this is sine of x times 1/2. I'm just going to put it in front, 1/2. Okay, plus, all right, the cosine here, the sine is radical 3 over 2 cosine x plus the cosine is 1/2 sine x minus, this is going to be radical 3 over 2 cosine x equals 1. Guys, these are like terms, these are like terms. When I combine these, a half and a half is a whole. I'm left with the sine of x. When I combine these, a positive radical 3 over 2 and a negative radical 3 over 2 cancel out. Equals 1. So who has a sign that's 1? Pi over 2. Okay, and the last homework problem in this set, okay, it wasn't set up like the other ones, but that's okay. So first again, I expanded the cosine formula. It would be cosine x cosine pi over 6 minus sine x sine pi over 6 minus 1 equals cosine x cosine pi over 6 plus sine x sine pi over 6. Yeah, it's a long one. Okay, now I'm going to substitute in what I know. I know the cosine of pi over 6, so this is going to be radical 3 over 2 cosine x. This is going to be minus 1/2 sine x minus 1 equals, again, this is going to be radical 3 over 2 cosine x plus 1/2. Sine of that is 1/2 sine x. Okay, I'm going to combine like terms. When I bring this to this side, when I subtract radical 3 over 2, and I bring it here, excuse me, it cancels out on both sides. Okay, so now I'm left with negative, I'm bringing this down, negative 1/2 sine x minus 1 equals 1/2 sine x. Add 1/2, add 1/2. I get a whole, I get negative 1 equals sine x. X is, who has a sign of negative 1/2, is 3 pi over 2. Okay, so that is the homework for that day explained. I'm going to make another video to do the next homework.